Hi, this is Mick Elliott from Electronic Specifier. I'm on the Seica stand at Productronica. I'm here with Luca Corli, and we're going to talk a little bit about battery pack testing, some of the challenges and the solutions that Seica can offer to the market. So Luca, over to you.
Hi. Battery pack testing. Okay, first of all, we have to look at the different technologies that are deployed to build the battery packs. Basically, today there are cylindrical cells, there are prismatic cells, and there are pouch cells as main elements to build a battery module or a battery pack. Let's say that in the automotive market today, different manufacturers are making different choices and they are using all three technologies, sometimes also mix it together. The experience of Seica today is more with battery packs made by cylindrical or prismatic cells. In these packs, basically, the idea is to connect multiple cells together in series and parallel to make the pack with the right amount of current and voltage needed by the car. And there is a high need of testing the connections between those cells. It's something that manufacturers are not thinking as first problem to solve, because in this market today, many players are beginners. They are very concerned about building the batteries, but manufacturing processes are not really mature, and test is something that they put for the moment on the side, and then they say, okay, we'll think about it. But if you do this, it could be too late. I just had the opportunity to read some statistics about the scrap that exists today in the battery manufacturing world. And there is, for example, a very famous car maker in Germany, I cannot mention the name, but basically they scrap 8% of their production when they produce battery packs, the equivalent of 140 millions per year. And why? One reason is that when the pack is already manufactured, if you have a failure in the simple connection, in the wires, in the bondings that are linking together two cells, there is no way to repair. And you just throw out the full battery in the recycle bin. So, Seica has developed a few years ago a special flying probe system that is able to measure the resistance of the connections that are linking together the different cells. We developed this initially for the cylindrical cells, where typically the value that you have to measure are in the range of the milliohms. And this machine is able to test a full battery pack made by, let's say, 500, 600 cells in 7 seconds. It's called Pilot BT. The same technology is now applied also for prismatic cells. In the prismatic cells, the main difference is that you have less cells, but the solder, the connection between the cells is not made by wire bonding, but is made by the bus bars or solid metal plates. And to be able to make the measurement, our flying probe is using very small coaxial probes where we can touch 2 points very close each other, right in the center of the positive and negative poles of the battery, of the cell. So my recommendation is don't skip the electrical test of the bonding connection, of the welding connections that are making battery packs, because some people are thinking, oh, we can do just AOI, or we can do X-ray, or there is another kind of test which is called pull test, where basically mechanically they try to pull the wire to see if it's attached or not, okay? But the parameters that must be measured are electrical parameters. We have to measure how good is the connection between 2 points. So we have to measure a resistance. And there is no better way to measure resistance than an electrical tester.
And you can do parallel testing on these batteries, is that correct?
Correct. In fact, we have 2 different models of flying probers dedicated to this market. We have one called Pilot H4BT, and in that case, basically, we can only measure 2 bondings at the time because the machine has 8 probes, and with 8 probes, we can measure 2 resistors with 4 wires. The other model, called the Pilot BT, has the ability to measure up to 32 bondings in parallel because we have multiple probes probing at the same time on the surface of the battery. The concept is exactly the same of the other machine, but just more probes attacking the board the battery at the same time, and making the throughput of the machine much higher.
I mean, I guess the attraction of that is it must accelerate the whole process of bringing these batteries through and getting them into the car.
Yes, absolutely. The fact that you can control before the full manufacturing of the battery the quality of the bondings, and there are no scraps and no recycles, will give you the ability, of course, to increase your volumes. But the most important is really the rate of scrap that is existing today in this process. Some car makers are thinking, or they are already doing this. They are building also their cells. Instead of buying cells from Asia, because basically most of the manufacturers are in Asia, in Europe the car makers are building up plants where they produce the cells. Okay. Also producing the cells as a failure rate, as a scrap rate. So another type of measurements that we can offer in our flying probers is the resistance of the cells, the unique cells, not the battery pack, but the single cells, from positive to negative pole. And this is another help, let me say, to reduce the amount of failures or the amount of scrap rate, to improve the efficiency and also to lower the cost. Because today in an electric car, the battery represents from 60 to 80% of the cost of the car. Okay? So there is a tremendous need of reducing the cost of the batteries. But if you have a failure rate of a few percent and you scrap millions of euros just because of your manufacturing process, it's hard to cool down and keep the cost at a reasonable rate.
I mean, it sounds like, well, it's certain that Seica have the technology. Is this as much an education job with the automotive makers?
Seica is a company that was born to make tests on electronic boards. And the process we see today in the battery environment is very similar to what happened, I would say, 35 years ago in the board test. People were mostly concerned on manufacturing to build the product. As I said before, test is an option, but let's speak about test later. The same process is happening today in the battery. So we really need to educate, let me say. It's probably not a good word, but we have really to let the customers understanding what benefit they can get by investing immediately in test and quality. I understand that now everybody, the EV market is booming and everybody wants to get to the next stage very, very quickly, But sometimes if they are too quick, they don't get there with a product. They get there with a prototype. Yeah. And it's not a good idea to having a prototype battery in your car. And
as you say, it's cost effective to actually test this up front, rather than, as you say, just, some of it goes to scrap.
Definitely, but we can prove that the return of the investment for an electrical tester for battery is so quick. I mean, when you talk about millions of euros going in the trash bin, a machine costs less than €1 million. So you can easily pay for the machine in terms of less scrap and in terms of quality, which means image also to your customers in a very short time. We need a big effort to do this because, again, customers are focused on manufacturing. We need a small effort from the designers of our customers, that they have to understand, if I have to put a probe in a location, they have to leave a little space around the bonding to allow us to put the probe there. This is the main discussion we have with our customers today. They come with their prototypes and we say, okay, Mr. Customer, if you want to do electrical test here, just give me 1 more millimeter. We're not asking for big size, but just 1 more millimeter free from the bonding, free from any other solder mask or whatever, to put a probe there and allow us to do the electrical test.
Okay. And Luca, if you just refresh us with the 2 products that Seica have in the market that address these problems.
Pilot H4 BT is a flying probe having 4 heads flying, and on each head you have 2 probes. So because when we measure this resistance, we need 4 probes per measurement. It's called Kelvin measurement. Yep. Pilot H4 BT with 8 probes can do 2 measurements at the time. And then we have Pilot BT, battery tester, which is our high-end machine. The machine has 4 flying heads, not individual probes. On each head, we can put up to 32 needles, and at that point, we can do 32 measurements in parallel at the same time. So let's say 16 times the throughput of the other machine.
Luca Corli from Seica, thank you very much indeed.
Thank you.